come up with a rule for multiplying complex numbers. Now, the rule we're trying to obtain is listed at the bottom of the page. So we're multiplying complex numbers in polar form because honestly, it is much easier than multiplying in regular form. When multiplying in regular form, every time you have to multiply, you have to FOIL and or double distribute, whatever you want to call it. And we are going to start there. But what you'll notice I've done here is I have written one complex number in polar form right here. Notice all the little ones on it. That's all that's different about our regular form. So I've added ones to everything. And here is my second complex number where I've added twos to everything. Nothing's happening here. And all I've written on the next line is, hey, I'm multiplying together, and hey, I'm multiplying them together. So at the bottom of the screen, you'll see that basically what ends up happening in reference to a normal polar number is the radiuses get multiplied and the angles get added together. So that's a little odd and surprising, but awesome. We're going to do this a little differently because I'm using my finger to write with right now. It is really sloppy and we need precision. So what I'm going to do here is going to be a little bit weird. So I'm going to pause the screen. When you come back, you're going to see a great big black screen, but I'm pausing. Just give it a second. What happened here is I'm not going to jump ahead. So what I'm going to do is I'm going to double rainbow this problem. And so I'm going to end up multiplying the first two terms, the next two terms, and so on. And when I am finished, I will get this. Now, I realize this thing is in the way, so let's just look at it. I know I can't quite cover the whole screen. Just bear with me. I wanted you to be able to see it. So what ends up happening is we get r times r2. That's right. So r times r2 right here. And then cosine 1 times cosine 2 right there. And then and then r times this one, which ended up being right here. And then this one times that one, which is right here, and then these two times each other. Now, the one thing that I did that was a little tricky is when I multiplied these, it's supposed to be I squared, and you'll notice I've written -1 because that's what I squared is. So I kind of fudged that one a little bit. Otherwise, all I've done is distribute. So what I want you to have on your paper, and again, we're doing this differently because I'm using my finger, and it is a disaster. I tried it like 8 times before I decided to go with typing it. So I've got this lovely thing here. And what I want you to do on your papers is record that line and also record this on the previous line. And then I want you to circle right here and write down that that was I squared R1 R2. And that way you have that for references later. So the next thing I did is I just rearranged it. And so because I am familiar with our things, I basically took the ones where, see how cosine and cosine are together here, and over here sine and sine are together, and here cosines with sine, here's sines with cosine. I thought, hey, maybe I'll put those two together. So I've grouped them. So the ones where the two angles matched are together, and the ones where the two angles did not match are together. And that's all that's happened here. This is just complete reorganization. So this is just the commutative property where I've rewritten things. I haven't done anything. I've just changed order and put some grouping symbols around it to kind of look at this two separately. And the reason I'm doing that will, I hope, be evident in a second. So all I did was rewrite. Record this line and then right next to it, rewrite. And then on my final line here, so I can get rid of this, my final line here, in both of these, in this one, let me get this, excuse me, that's where we're going to practice. In my final line here, I've factored out from the previous line the two things that match. So there it is. And on this one, the things that matched. So there it is. And that's all that's happened here, just a bit of factoring. So again, mark appropriately, write factor next to it, whatever helps you understand what's happening. Now here's where it gets a little tricky and where I have to remember stuff. So down here at the bottom of the page, I have now the sum and the sum identities for sine and cosine. So you'll notice with sine, I end up with two different angles. So that's probably the stuff here at the end, which we'll stare at in a minute. And cosine end up with the same angles. We're going to stare at that one first because at the beginning. So I've got something out front, that doesn't matter, but this stuff inside, which is cosine of one angle times the cosine of another angle minus the sine of the first angle times the sine of the second angle is cosine alpha plus beta. So all I need to do is rewrite this, and I am going to write now, and you'll see why I didn't write the rest of the time. I've got R1 times R2. And then this whole line becomes cosine, and I'm going to erase this last parenthesis because I'm silly. This becomes cosine of cosine 1 plus cosine 2 because that's our alpha and beta. So they just trade. They just go in and we're all set. So it's no big deal. Nothing's really happened. I don't really need these parentheses out here. I'm using them. And then over here, the same thing, except for this one, I'm going to stare at sine here. Sine is alpha times cosine plus alpha cosine times sine. And if we look at here, cosine and then sine, sine, then cosine of my two angles. And that's kind of what's happening here, except for that it's backwards, right? We have this one is that one, and this one is that one. But since it's just addition in between them, that doesn't make any difference. And so we can rewrite this statement right here. I'm going to erase a lot of things. So that statement right there as, so plus I R1 R2 times the sine of angle 1 plus angle 2. And I'm going to just move that over a little bit. Now, while I'm thinking to myself, this is not very clean, isn't it exactly what's at the bottom of the page? So if you look down straight underneath this, this is where my goal was the whole time. This is right there, and this is right there, and so I finished. So basically what I've done is basically show you that this is true. Now, you don't need to remember this, why it's true. You do absolutely need to remember that is the way to multiply. So let's just try it, because it seems awkward, and I'm going to do one example, then you're going to do two. So what do? Well, it said we multiply the radiuses and add the angles. That's all we do. So I'm going to do, my radiuses are 3 and 5. So I'm going to do 3 times 5. Okay, that's our cosine of the first angle plus the second angle plus I times 3 times 5 sine of the first angle plus the second angle. And this is running right off the page and you can barely see it, but we'll do our best. 1, 2, 3 plus 4. Anyway, close the parentheses. So exciting. So I'm just going to clean this up real fast. I get, not in white, 15 cosine of 164 degrees plus I 15 sine of 164, and I'm finished. It's really, that's all there is to it. It's just multiplying and adding. And if you think about all the work we had to go through to get here, this is the best shortcut in the entire universe. So go ahead and try some, pause the video, and I'll be right back to explain division and the answers, of course, to these problems. So this one, my answer is going to be 56 cosine of 98. That's what 63 plus 35 is. 98 degrees plus I, 56 sine of 98 degrees. All finished, done. It's just, that's how fast I did that problem. That's how easy it is. This one becomes 12 cosine of 47, good number, plus I 12 sine of 47. And that's it. That's all there is to it. It's done. It's really, really easy. Let's look at division, which we're not going to prove, by the way, so don't freak out. Here's the division rule. There's not room to prove it. It's very similar. The difference, of course, is that instead of multiplying the radiuses, we divide them, which makes sense since we're dividing. And instead of adding the angles, we subtract them. And it's that simple. So again, I'll do one example, then you will do the other two. In case you didn't know, this is the rule you need to remember. Sorry, I'm going a little fast because I'm running out of time. And you're running out of patience. So that's the rule I'm going to use. Here we go. So I'm going to divide, and so 20 divided by 5 is 4, and then I'm going to subtract. So 4 cosine. And if you can't remember the order, just look at the problem and steal it. It's really awesome. And 210 minus 103 is 107 plus I, and then 4, and I'm running out of space here. So let me move this. Sine of 107. And I'm finished. That's it. That's all there is to it. So go ahead, pause the video, and do the other two, and I'll be back with the answers in just a second. And we're finished with, well, almost, because I'm going to show you one more thing, but almost finished. Two answers, 4 times the cosine of 51 plus I 4 sine 51. Need to be consistent and have parentheses on all those. 9 cosine 38 plus I 9 cosine 58. That's it. This is the hard part. It's no big deal. What I realized I forgot to demonstrate was changing forms. I don't know why I didn't do that in the last video, but let's do that really fast. Let's do the scary one, number 11. And so I need to figure out what r and theta are. So this is going to be my x, and that's going to be my y. So r is going to be the square root of 3 squared, and this is 1 plus 1 squared equals 3 plus 1, or 4. And so r is equal to 2. And then we need to find theta, and so theta is equal to 1, the tangent inverse of 1 divided by radical 3, or we know that's the square root of 3 over 3, which for tangent is 30 degrees. So tangent is 30 degrees. I mean, theta is 30 degrees, excuse me. And so now that I have r and theta, which we practiced yesterday, so which is why I didn't go over what, now that I have those, number 11 quickly becomes, and it says trigonometric form because that's easier. So it's just going to be 2 parentheses cosine, not a C, cosine of 30 degrees plus I sine of 30 degrees. That's it. All finished. So make sure you practice, and I will be back another day to bother you. The end.